Okay, so the point that I would like to make today and make sure that you understand very clearly, does everybody see the equation that Hernando and Rachel are trying to solve? Okay, oops, I kind of cut off that M there. Hold on a second. How many types of variables does this have? Do you agree that m squared and m are essentially two different variables? They do not go together. Agreed? Okay. How many types of variables does something like this have? Just one. Do you agree that these m's are the same kind of variables? If we were going to solve this bottom one, we would get the m's together and we would isolate. Agreed? Okay, if you have one type of variable, you will be isolating. If you have two types of variables, you have to set it equal to 0, and then you have to factor. Okay, so now that we have made that crystal clear, who is correct and why? Rachel is correct because she set it equal to 0. So can you please, there should be some white space to the right for you to write me a sentence that says who is correct and why they are correct. You should have, yep, a little bit of white space over there. Make sure you start your sentence with a capital letter, please, and end it with punctuation. Rachel is correct because she set it equal to 0. So let's just follow what Rachel did here when you're finished, because this is what we're going to be doing today. Excuse me. How do you get this thing set equal to 0? What do you have to do? I got to move this over here by subtracting it, correct? Do you see how she did not put those together? Because they can't go together. Okay, so now that we have it set equal to 0, now I need to factor it. What's the first thing we look for when factoring? A GCF, something they can both be divided by. What can I divide both of those by? 2 and m. So she took out a 2m. Does everybody see that? And then when you divide by that 2m, I have m minus 2 left. Fair enough? Okay, so this is a factor, and this is a factor. Do you agree that this parentheses means multiplication here? And in order for me to multiply two things together to be 0, either one of them has to be 0 or the other one has to be 0. Fair enough? Now we can isolate. How do I isolate this m? Divide by 2. What is 0 divided by 2? How do I isolate that m? What is 0 plus 2? And those are my two answers, and thus Rachel is correct. Fair enough. Do you see how Hernando tried to isolate by dividing by this 2? Can't do that, guys, because of the two different types of variables. Okay, let's do another one like that. Now I've got Jerome and Charles. Does everybody see that Jerome and Charles are not solving this? Do you see that there is not an equal sign in this trinomial? Everybody crystal clear on that? They are just factoring it. So the first thing you look for is a GCF. Do you have a GCF? You do not. And that's a trinomial, agreed? So what are you supposed to make? You're right. What are those? Binomials, right? Parentheses that are binomials. Did they both make binomials? They did. What are those binomials supposed to start with? Did they? Uh-huh. Then you're asking yourself for factors of that will subtract to 6. What factors of 16 will subtract to 6? 8 and 2? Is that okay for everybody? Did they both use 8 and 2? So far, they're both right. Now, if we were subtracting, what does that mean about my symbols? They have to be different, and the bigger one has to be add. Which of them made their bigger one adding? Charles. So he is correct. If you would please write me a sentence that tells me why Charles is correct. Should say something to the effect that he has his symbols correct. I'm doing okay? Anybody have any issues with those before we get on to our regular problems for today? We're all good? Okay. I do have one follow-up question, though. What would Jerome get? He's not going to get that, but he's going to get something close to that. If he has his minus with the 8 and the plus with the 2, what is he going to get for his trinomial? Yeah, he's going to get a negative 6 right here instead of a positive 6. Does that make sense? All right, so let's fill in a little bit here. What's your first step? Always looking for a GCF. Please remember that the GCF has to come out of everything. You can't just pick and choose. It got to come out of everything. Then if there are 4 terms, we're going to group. Okay. Then we learned if there's 3 terms, what's that called? Binomials. I can't wait for somebody to listen to the recording and hear that and be like, what the heck is she doing? 2 binomials. Yeah. All right, so now I'm going to go back up to this warm-up here. How do 2 factors that are multiplied together equal 0? Not necessarily variables. You're on the right track, though, Dalton. How do I get these 2 things to multiply to be 0? One of them has to be 0. Does it matter which one? No. One of them must be 0. One of them must be 0. Which means we have this thing called the zero product property. Okay, and the zero product property says set your factors equal to 0. And then you're going to solve them. Absolutely. Oh, that says the solve. That should say then solve. Okay, so we've got these problems to do. I have like 3 more I'm going to add at the end of this, and then we'll be done for the day. Okay, so not too bad. We ready to go? We're going to do the first few together, and then I'll start going around the room. Take a look at number 1. How many types of variables? 2, which means I have to set it equal to, how do I set this thing equal to 0? We're going to subtract the 9y from both sides. Do you get to put the y squared and the 9y together? No, but I want the y squared to come first. Everybody doing all right? Do you have a GCF? What is the GCF? Y. They both can have a y taken out. If you take out a y, what's left? Okay, is everybody following Savannah here? Do you know where she gets that from? I subtract those and I get 1 y left in there. Those y's cancel and I just have my minus 9. Is that okay? Look, you good? Okay, now I have my 2 factors, don't I? So I'm going to say either y can be equal to 0 or y minus 9 can be equal to 0. Now, there's some good news here. This y is already isolated. So that's my answer, one of them. 0 is one of my answers. How do I isolate this y? Add the 9. So then my other answer is 9. We did. Good. Correct. I think we did these binomial ones before. I don't think we've done the trinomial ones. Okay. I think. Correct. Do you guys see how this thing in the parentheses had 2 terms? I don't have a thing to do with 2 terms right now, do I? Eventually we will. Right now we don't. Let's go over to number 2. First of all, how many types of variables do you have? 2. R squared and R. Got to get it equal to 0. How do I do that? I'm going to, we're going to minus the 20R. Now, folks, I want to be strategic on how I rewrite this. Where should I put the 20R? Basically right in the middle, correct? Folks, when we do this, it should be squared and then regular variable, then no variable. That's the order it should go in. So 2R squared minus 20R plus the 18. Okay, first question is there a GCF? What can I divide them all by? By 2, all of these. are divisible by 2. So we're going to pull a 2 out front. If I divide them all by 2, what's left? R squared minus 10r plus 9. Is everybody following all right? Now, how many terms is in here? What do we make with 3 terms? Binomial times a binomial. So we're going to do that. Please notice this 2 out front is going to get dropped down right at the beginning. That 2 is coming straight down. All right, so here's what you're asking yourself. Well, first of all, what am I going to start them with? R's, right? I want factors of 9 that will add to 10. 9 times 1. Is everybody all right with that? Does this symbol right here mean the same or different? And they both have to be subtraction. Now, there are 3 factors here, folks. I have 2, I have r minus 9, I have r minus 1. You're setting them all equal to 0. Now let me show you something. What happens here? Is there a variable to isolate in this factor? Does 2 equal 0? Does 2 equal 0? It does not. That does not get me an answer because there's no variable with it. Okay? Now these other 2 are hopefully very easy for you to solve. How do I solve the next one? Add the 9. So r is that okay? How do I do the next one? And r is 1. Okay, we'll do one more together, and then I'm going to have you guys start doing it for me. Yep. Not alone. I'll be helping you. Yeah. Number 3. Is it equal to 0? Great. Is there a GCF? All of them are divisible by 5. So we take the 5 out front. What happens to these 5s? So I just have m squared left. What is 20 divided by 5? And I have the m left. And how about that 20 divided by 5 is just 4. How many terms are in there? So that means I'm going to make 2 binomials, and I'm going to drop the 5 out in front again. What are they going to begin with? And you're asking for factors of 4 that will add to 4. 2 and 2. Still doing okay? You guys all sound lovely today. I know. I'll stay far away. That's all right. Well, it's not their choice. Well, eventually. Folks, what does this symbol here mean? Same, and they both need to be. Now, do you see the 5 that's out front again? Is there a variable with it? So it's not going to get me an answer. Don't even bother, okay? Do you see how these 2 factors are the same? They're going to get you the same answer. Just write it once. You don't need to write it twice. How do you solve it? So m is wonderful. How do we feel about the front here? Good. All right, so let's go ahead and go to the back, and we'll go around the room. And like I said, I've got like 3 more I'm going to add on here. Anybody want to start? Start? I got to get it equal to 0 first. What are you going to do? What part do I need to move over so I can make it a 0? Yep, how do I move it over? Perfect. What would the new equation be? Okay, first question is there a GCF? No, there's not. But there are 3 terms, so what are you going to make? And what are they going to begin with? Okay, in your head, you're asking for factors of 24 that will subtract to 2. Some numbers that multiply 6 and 4. If we are subtracting them, that means they have to be, and the bigger one has to be plus. How we doing here, folks? You following okay? All right, set up your 2 equations now, Dylan. How do you solve the first one? So what do you get? Wonderful. And in the second one? So y is, how we doing, guys? Can I show you that this math is not made up and that it actually works? Can I prove it? Well, I'm going to prove it to you just once. I'll just do it once today and then we'll leave it go. Grab your calculators. Would you like to try this -6 or the 4? Which one? Okay, we'll just do the -6 because it's first. Do you see how that's supposed to be my answer, right? So if we type this into our calculator, now notice I put a parentheses around that. When you hit equals, what should this thing equal? No. It should equal 24. Can you do this for me? It is 24, right? Okay, this is not made up. It actually works. Should be 24. We all good? Okay, let's go on to number 5. Cody, you're up for number 5. I got to get it equal to 0. What am I going to do? Wonderful. And when you do that, what's your new equation, please? Wonderful. Do you have a GCF that you can take out of all of those? You don't. But there's trinomial, so what are you going to make? 2 binomials, starting with, wonderful. And you're asking yourself for factors of 27 that will subtract to 6. 2 numbers that multiply to 27 but also subtract to 6. Give me a second. So if I was doing this on my calculator, I'd do 27 divided by, and I just start trying some numbers. What do you think? What are you trying to divide by there, Cody? 27 divided by what? By 6? Does that work? Try something else. 27 divided by 2? I don't think that's going to work either. Try 3. 27 divided by 3. What'd you get for 3? 3 and 9. Do you agree, Cody, that those will also subtract to 6? Okay. Now, since we were subtracting, does that mean same or different? And the bigger one has to be positive. All right, now we're going to set up our equations here, Cody. How would you solve the first one? So what's my answer? Wonderful. How would you solve the second one? And the answer is wonderful. Looks good. All right, Mr. Stahl, good news for you in number 6. It's already set equal to 0. Is there a GCF? No. Even more good news. How many terms you got up there? 3 terms, right? So what are you going to make? 2 binomials starting with. You're looking for factors of that will subtract to 3. Factors of 18 that will subtract to 3. Yep, so 18 divided by, what are we trying? 2. What'd you get, 2 and 9? Do those subtract to be 3? No, try again. 18 divided by, there you go, that'll work. If we're subtracting, does that mean same or different? And the bigger one has to be wonderful. Now you're ready to set up your 2 equations? How do you solve the first one? So what's x? There we go. And the second one? So what's x? Wonderful. First row's done. Doing all right? Yeah? Who's next, Savannah or Dalton? You? Okay. Is the next one set equal to 0? No. So what are you going to do? Now, I'm a little nervous about this, Dalton, because 140 is a big number, isn't it? So what's your new equation? Yep. Do you have a GCF? That's okay. Is that okay too? So we're going to divide everything by 2, and we're going to put a 2 out front. What's left when you divide everything by 2? Uh-huh. Uh-huh. What's 140 divided by 2? Okay. And you agree that's a trinomial in there, right? So we're going to make 2 binomials. Don't forget to drop your 2 out front. And those binomials are going to start with what? Wonderful. You're looking for factors of 70 that will subtract to 3. Now, folks, when you're doing this, do you see how that 70 ends at a 0? Yes or no? That automatically tells me you can try dividing by 10, 5, and 2. Those would be the first things that I try because it ends in a 0. So, Dalton, can you find me any factors of 70 that will subtract to 3? So 10 and 7, wonderful. If we are subtracting, they have to be same or different. And the bigger one has to be, subtracting. Now, does everybody see the 2 that's in front? Is there a variable with it? No, so will it get me an answer? No, so don't waste your time. You only get an answer if there's a variable with it. All right, Dalton, how will I then solve my first equation? Wonderful. Wonderful. Perfect. So if you were to plug this in up top there, and you press your equals button, it better equal 140. Okay, that's what we're doing. Savannah, number 8. Good news, it's already set equal to 0. Bad news, everybody see how it starts with a negative? I don't like that. So let's make that our GCF, Savannah. Okay, yep, we're going to divide everything by -1. We're going to take that -1 to the front. Can you tell me what would be left, ma'am? Basically, when you take out a -1, folks, all of the symbols just make the opposite. Do it okay? Savannah, how many terms do you have inside of there? So we're going to make 2 binomials, and we're going to drop our -1 out front. What are they going to start with? Now, I feel like we've already had this one, Savannah. Factors of 18 that will subtract to 3. You guys see how these numbers keep showing up over and over again? You got to start remembering them, okay? Make your life a little easier. She says 6 and 3. If we're subtracting, does that mean same or different? And the bigger one has to be addition. Now, Savannah, that -1 out front, does it have a variable with it? So it's not going to get me an answer, so don't bother with it. Set up your 2 equations. And what kind of an answer will you get from the first equation? -6 because we have to subtract the 6. Does that make sense, though, Tyler, why we subtracted it? Because I think you said positive. And how about the other one? +3. Good. All right, who's next? Luke or Derek? Derek's next. Okay, is it equal to 0? Wonderful. Got a GCF? Got a GCF? Yep, divide them all by 3. Pull that 3 out front. What's left, sir? Wonderful. Drop that 3 down. Oh, yep. Thank you. So let's see if he's right. Do you all agree that 5 times 4 is 20? Do you agree if I subtract 5 and 4, I get 1? So we're good. Do you also agree these symbols were supposed to be different? And the bigger one was supposed to be negative. Right there, negative. Okay, does this 3 get me an answer? No, don't bother. How do you solve the first one, Derek? And the second one? Wonderful. I'm not quite sure this could go much better for us today, guys. This is what you're going to be tested over on Friday. We're doing more of this tomorrow. More of this tomorrow. Okay, same thing. All right, Luke. Here's number 10, and then we're going to add. We're not going to add all these, so don't worry about it. You ready? You have number 10, and then we're going to add these other problems onto your sheet, okay? Is number 10 set equal to 0? How do you get it set equal to 0? Okay. So what's your new equation? Now you can't put those together, Luke. One's an x and one's not an x, right? So leave them separate. You got it. And then we have our equals 0 on that side. Do you have a GCF there, sir? Can I divide all three of those things by the same thing? No, so no GCF, but it is a trinomial, so I know I got to make two binomials. What are they going to begin with, Luke? And you're looking for factors of 15 that will subtract to 2. Numbers that multiply to 15 but also subtract to 2. What kind of numbers multiply to 15? And 5 times 3, do those also subtract to 2? They do, so those are the numbers that I want. Good guess. If we're subtracting, Luke, does that mean same or different? And the bigger one has to be adding. So the 5 is adding, the 3 is subtracting. All right, go ahead and set up your two equations. Does everybody realize that I wouldn't have to do this setting up my equations thing if there was no equal sign? Yes. We just stop at the two binomials. Luke, how do you solve the first one? Wonderful. How do you solve the second one? Wonderful. Okay. Now, I know that nobody ever wants to add problems to their notes, but why are 11 and 12 really not a big deal? They're already equal to 0, first of all. Do you see how there's already two binomials? That means they've already been factored for you. So all you have to do is the very last step. And what is that very last step? Yeah, you're just going to separate them and make them equal to 0. Folks, do you see how I used that 2m out front because there was a variable with it? How do you solve for it? So m is the second one. You add the 10, so m is 10. Okay, how is that okay? Not too bad for an extra problem, right? Let's look at number 12. Do you agree number 12 is in the same situation? It's already equal to 0. The parentheses are already there for you. So all we have to do is set up the two equations and solve. Now I got some people fourth period on this. What would you do in the first equation? You're going to add the 7 first. So now I have 2x equals 7. 7 divided by 2. 3.5, you also could say 3.5. To be honest, you could have left it as 7 over 2 if you wanted. Okay? How do you solve the second one? And then, what is 1 divided by 3? It's either 1/3 or 0.3 repeating. You're thinking of 3 divided by 1, Tyler. Okay? How's everybody doing? Good? Okay, pick one. This one doesn't even have a number, does it? 14? Okay, let's do 14. Is it set equal to 0 for you? Yes. Has it already been factored for you? No, it hasn't. So ask yourself if you have a GCF. What? Now, do you see how it starts with a negative? I don't like that, so we're going to divide by negative 7a. And that will go out front. If you divide that out, do you see how the negative 7s will cancel? How about my a's? Just an a. What is 21 divided by negative 7? And the a's cancel. Now, this is 2 terms in here, correct? So you can't do anything. I can't do a binomial for 2 terms. That's only for 3 terms. Now, will this negative 7a out front get me an answer? It will, because it has a variable. How do you solve for it? So what do you get? And you get? Wonderful. We doing okay? Okay, so this is your homework. More of this. Okay, I will caution you. Please be sure you write things in the correct order. You always want to have your squared thing first, then your regular variable, then no variables. Make sure they go in the right order. Okay, so Tyler, why don't you get that thing out for me so I can look at it? And you probably can get that worksheet done so you can turn it in before you go, okay?